Paleontologists from the University of Portsmouth have discovered two new fossil teeth from the Cretaceous rocks of Dorset. They are from the branch of the mammal tree that led to modern mammals, including humans. Their findings suggest the origin of modern mammals lies even earlier in geological history, as supported by previous fossil finds from China. The new fossils were found by an undergraduate student, Grant Smith. Grant was sifting through small samples of earliest Cretaceous rocks collected on the coast of Dorset, in the hope of finding some interesting remains, said Dr. Stephen Sweetman, a research fellow at the university who led the research. Grant knew he had a mammal, but didn't realize he'd discovered something so special. Unexpectedly, he found not one, but two quite remarkable teeth. Grant and his supervisor David Martle, the paper's co-authors, called on Sweetman to take a look and give his opinion. Sweetman recalls, "My jaw dropped. I realized straight away I was looking at remains of early Cretaceous mammals. Two fossil teeth of the Purbeck Mesozoic mammals, Duralstotherium A14 and Duralstodon B14, named after Durlston Bay in Dorset. These Jurassic mammals are ancestors to placental mammals, and are oldest of their kind found in Europe." Photograph SCS Sweetman et al. 2017 https www.app.pan.pl Article 8 Map 00408 2017.tml These teeth belong to two different animals, both members of the group known as Eutheria, the group that includes all modern mammals. They have been named Duralstodon and Duralstotherium, after Durlston Bay in Dorset, where the fossils were collected. Mammals are animals that possess fur, feed their young on milk, and have complex specialized teeth. They have their origins in the Triassic at the same time as the dinosaurs. They split into many different groups during the Jurassic and Cretaceous, including branches that died out long before the impact that killed the Niovian dinosaurs. The groups of mammals that survived the extinction event include the monotremes platypus and echidna, the marsupials such as kangaroos and koalas, the multituberculates which then died off around 35 years ago, and the eutherians, or placental mammals. This last group is now the most successful mammal lineage on Earth, having evolved creatures as diverse as the blue whale, the grasshopper mouse, and Homo sapiens. Fossils from the first placental mammals are relatively rare in the UK. While these Dorset fossils may seem underwhelming, comprising only two molar teeth with no roots, the unique specializations of mammal teeth for processing food result in complex tooth shapes. These shapes evolve in patterns that allow paleontologists to pinpoint what group a mammal belongs to, meaning that even a handful of teeth allow scientists to identify new species. A mandrill monkey yawns in his enclosure at the zoo in Dresden, eastern Germany, showing off his complex teeth and sicors, canines, premolars and molars. Photograph Matthias Heathcliff PGT Images The evolution of mammals has been well fleshed out since the first mammal from the Mesozoic, the time period that includes the Triassic, Jurassic and Cretaceous, was found in English Jurassic rocks in the early 1800s. Recently, new fossil discoveries, particularly from China, have transformed our understanding of early mammals. Whereas researchers used to believe Mesozoic mammals were simple, rat-like animals cowering in the shadows of dinosaurs, we now know that by the end of the Jurassic, various mammal lineages were experimenting with different ecologies, including otter-like semi-aquatic forms, and mole-like diggers. Even 160 years ago, mammals were more diverse and successful than anyone had previously suspected. However, there are still some gaps in our knowledge. The exact origins of Eutherian mammals is among them. The earliest Eutherian mammal currently known, Jeremiah, was described in 2011. It comes from the Jurassic rocks of Tiaojishan Formation in China, and is around 160 years old. The fossil skeleton includes jaws, forelimbs, vertebrae and ribs. Jeremiah predates the Purbeck mammals by 15 million years. This suggests that if Eutherian mammals had their origins in Asia in the Jurassic, they had spread across the continent to Europe by the early Cretaceous. Jeremiah, a Jurassic Eutherian mammal ancestor. Fossil found in the Tiaojishan Formation, China. Composite Jaxi Luo Mark Klingler Carnegie Museum of Natural History. It is clear that the early Cretaceous of the UK had Eutherians, said Professor Jaxi Luo of the University of Chicago, a world expert on mammals of the Mesozoic. These fossils are a very interesting hint that Eutherian mammals were already present in Western Europe at this time. Trying to work out exactly when Eutherians originated is not straightforward. Paleontologists use the anatomical shape and characteristics of fossils to work out how extinct animals are related. By giving these characters numerical scores, they can use computer programs to work out the complex networks of relationships mathematically. So, for example, if a tooth possesses a certain cusp, it can be given a score of 1. If it does not, it can be scored as 0. These numbers are fed into programs that map out different possible family trees based on the scores. It also gives the statistical likelihood of each branch on the tree being close to the true relationship, or not. This branch of science is called phylogenetics. It is one of the most important methods used by modern paleontologists, and a common component of published papers describing new species. To work out relationships between living mammals, scientists can use molecular data. As there is no molecular data for fossils, paleontologists often combine the molecular results with those generated from the fossil anatomy. But this can lead to problems when the molecular results don't match the results found using fossils. The origins of eutherian mammals is one such problematic case. Sweetman and his colleagues suggest that Duramava might not be eutherian at all, based on a study which estimated Eutheria had its origins only 91 years ago. But other estimates have placed the origin at up to 193 years ago, a whopping 100 years earlier, and comfortably encompassing Jeremiah. The hypothetical placental mammal ancestor, a small, insect-eating animal. Illustration: Carl Buell, American Museum of Natural History. The discrepancies between these results are caused by differences in the data used to calculate them. For example, an analysis with lots of modern mammals and only a few fossils will tell you a lot about recent branches of the family tree, but not give useful information about ancient relatives. Paleontologists therefore consider the results of phylogenetic analyses as theoretical. They are constantly refining and adding to the data, fueling continued research and debate. Jeremiah, Duralstodon and Duralstotherium all fall inside the range of estimates for the origin of eutherians, so they are currently the 3 oldest eutherians known. The new Purbeck mammal teeth are an exciting addition to the impressive list of Mesozoic mammals known from the United Kingdom. Their age makes them the 2nd oldest placental mammals ever found, proving that there is still plenty to learn about the Jurassic and Cretaceous fossils of this small Atlantic island. Martel added, the Jurassic coast is always unveiling fresh secrets, and I'd like to think that similar discoveries will continue to be made right on our doorstep. References: Luo ZX, Yuan CX, Meng QJ, and GQ 2011. A Jurassic Eutherian Mammal and the Divergence of Marsupials and Placentals. Nature, 476. Meredith R.W., Janecasia, Gates C.J., Ryder O. Fisher C.A., Teeling E.C., Goodbla A., Ikuriki, Simo T.L.L., Stadler T., Rabowski D.L., Honeycutt R.L., Flynn J.J., Ingram C.M., Steiner C., Williams T.L., Robinson T.J., Burkera K., Westerman M., Aobna, Springer M.S., and Murphy W.J., 2011. Impacts of the Cretaceous Terrestrial Revolution and KPG Extinction on Mammal Diversification. Science, 334, 521,524. Ullery M.A., Block G., Flynn J.J., Godin T.J., Jalambordo A., Giannini N.P., Goldberg S.L., Krotz B.P., Luo Z.X., Meng J., Niex, Novasic M.J., Pernini F.A., Randall Z.S., Ruger G.W., Sarja C.J., Silcox M.T., Simmons N.B., Spalding M., Velasco P.M., Wexler M., Whipple Jr., and Siren L.O.L., 2013. The Placental Mammal Ancestor and the Post-KPG Radiation of Placentals. Science, 339, 662,667. Sweetman S.C., Smith G., and Martel D.M., 2017. Highly derived Eutherian mammals from the earliest Cretaceous of southern Britain. Acta Paleontologica Polonica.